Welcome to Architectural Engineering Student once again, and this is part 2 of our anti-topple structure, resisting what's to be hurricane and tornado. And we get into this portion here then. This is some kind of estimated cost, about, a little over $5.5 million in 2007 dollar. And this has conditions, they'd be the tornado roof uplift resistance for this particular thing is 950 pound per square foot, something like that, and that's said to be good enough for our tornado resistance. So this started out being 4 feet, and it was changed to 6 feet during the calculate. What this shows is a 2-foot breadth in here that one could lay down in. There's one block here, one block here, and this block here it spans that 2 feet. And here's that block on the top spanning that 2 feet, and then here's these blocks underneath that occur there. And it's ended up being about 18 feet by about 18 feet there. There's a 2-foot opening here, and then there's this 2-foot linear space that's created by those blocks stacked on each other. And here's the elevation. There's 3 blocks here, and then there's 4 stacked on top. 2 foot here and 2 foot here. And then these 3 blocks here then are supporting that block there. That's our concept, and what's to be a hurricane proof, and it's tornado proof also, shelter. And A sub A is less than 0.20 G by the discussion we had previously. And that's said to be a world minimum. And we're saying that F sub T, our bending stress and tension, for that particular bending element here, this roof portion, is stated to be 45 psi, and that W sub W, the air pattern loading, is 130 pounds per square foot. So here's a calculate that says 150 pounds per cubic foot times 4 feet times 4 feet times 1 foot. That ends up being 2,400 pounds per lineal foot that occur there per square foot per foot in length of the thing as it is. And we're saying that this maybe is applicable at greater than 40 degrees Fahrenheit. These things are not stated to be waterproof, and water will leak in the interior when it's raining. And so the statement is you don't want it to be very cold in that particular condition. So that'd be unreinforced masonry and stone, and it's said to be granite. Where this is the right weight for that, I have no idea. This is more of a concrete weight than a granite weight. So we have M is equal to WL squared over 8, and then that's 24 inches times 2 feet squared times 6, and that ends up being pound feet as it is, something like that. Well, the weight is actually 2,400 pounds per lineal foot times 12 inches per foot, and that equals in 14,400 inch pounds or pound inches, depending on how you like it. It doesn't matter which one you answer, it's going to be the right answer. And what's going to be that force couple in a moment. So we have the bending stress F sub B, which is MC over I. C is 48 inches, and then we have B, I is equal to BD cubed over 12. And so we have 48 times 48 cubed divided by 12, and that's 48 to the 4th divided by 12. That's 442,368 inches to the 4th. Our S sub T then is MC over I, 14,400 pounds per as pound inches. Then times 48, and I don't know what this was here, but this wasn't quite right, but we'll go ahead and get those here, and this will be pound and then inches here. And so in this portion here, times 48, then divided by the I, which is 442,368 inches to the 4th, that ends up being 48 psi, and say, well, that just isn't good enough. Because that's 48 psi greater than 45 psi, which is our F sub T for the material, so that's no good. And so therefore the beam would break, and the condition would not be satisfactory. So then the one says, well, try this 6 foot by 6 foot by 6 foot, and the M then is said to be 2,700, I think it is, inch pounds, and that's 33, actually foot pounds. That's 32,400 inch pounds. Well, I is then 72 times 72 cubed divided by 12, and look at the big I you get here, 2,239,486, just by adding a couple of feet in depth there compared to this 442,368. We have S sub t then is equal to 32,400 times 72 divided by 2,234,000, if not 2, yeah, I think that's 234. That's 239 actually. 2,239,480. That's 1.04 psi, less than 45 psi. Okay. So surface life is in thousands in year. It's all unreinforced. It's granite. It's a block that's 6 foot by 6 foot by 6 foot, and it creates a hurricane and tornado shelter when A sub A is less than 0.20 G. That's our world minimum condition for that. And so there you go. That's a successful preliminary speculative design for such a condition. Page 3. 3 of 3 in our discussion in creating hurricane and tornado shelter using unreinforced stone block as we have the consideration in the anti-topple condition. And that's this time in Architectural Engineering Student.